Anyone?
Yes.
Did you do it?
Yes.
And did you get it right?
I don't think so.
Did you do it on the paper, or
Yes, on paper.
would you mind to share the screen?
I don't have a camera.
What are you using there?
Desktop. I don't
Uh,
have a camera.
okay. So you are the only one who has done it. Anyone who has done it? Okay, it's fine. Time now is no longer on our side. Determine the minimum cylinder mass M required to cause a loss of contact at A. So they want us to determine the minimum mass here required to cause uh, the loss of contact at A. So basically what they want is they want uh, this they want down, and the pushing will be caused by this mass here. So they want the minimum M here. So first things first, you just look at it and then you draw the free body diagram. Okay? So by looking at this from the free body diagram, this is how it's been drawn. I'll start at A. So at A there, because this was resting on the wall, this is the reaction. So it was applying a certain force at that wall. So here's the reaction of that force, and this here will be the weight, will be the weight. So it's twice mg over 3, and these are the length. And then if here we've got the reaction here, ox oy, and then also here we've got the weight of this, and this being the length, and here we've got the t. Yeah, so we've got 1t, or we've got the t here. Let me not say 1t. And as it goes down, it comes to this m, where our m is m1g. So that's how the free body diagram is being drawn. Okay, then
Okay. Then
yes, sir.
yes.
I'm
I'm
listening.
listening.
I'm listening, sir.
There was just feedback, sir.
Come again.
Someone's mic was on and then there was some feedback.
Oh, okay, all right. Okay, then once you are done with this, yeah, you can straight away take moments at this point, and you can say, or they've said that they've taken anti-clockwise as positive. They've taken anti-clockwise as positive. So this year it's sitting at an angle, so it means we'll have 30. The angle there is 30. If the angle there is 30, we'll also get 30 around here, somewhere there. So if you were to take moment, you know now the law of moments there. So you'll have this force at an angle with a total distance there. So it will be 2 mg over 3 L at an angle for this force, and for this one, it will be mg over 3, also with L over 6 cos 30. And for the T, or for this one, then you consider your T as mg over 2. T as mg over 2. So instead of writing T there, you just say mg over 2 with the length there of the total length there to that point, which will be 1 over 3. And when you do your maths, this is what you will find. So your m there, you make your m the subject there, and then you'll find that your m1 will be 0436. Kekana?
Yes, sir.
Okay. When I call your name, I just want to confirm whether I'm still on.
No problem, sir.
Okay. Yes. The guy, I can't see your name yet. The guy who said he has done it, are you still there?
Yes, sir.
What did you get?
0.1.
0 point. Did you apply the same principle or something different?
Now it's something different.
Okay. And then the rest of you guys, any question?
Sir,
Yes.
this thing is confusing, sir. Ne? How did you know that 2 is the mass, sir? Because now I say the length is 2 over 3.
Say the length is what?
2 over 3. How do you know that the mass of that rope from A to O is 2? How do you actually know that that's the mass?
Okay. You see here, they've given you the ratios there. So we've got 2L over 3, and then here we've got L over 3. And this was, it's just that they didn't mention it there. But what they've done there, here on the mg, what they've done is they've just removed the L there, then they put mg. Do you get that? So meaning that the length, they've replaced the length with the mass and the gravity, because they're working with the ratio. And they've taken, if you check here, they've taken, or they know that from there to there it's 2 lengths. So if they have it, and then it will be 1 this side and 1 to the other side. Are you there? Hello? Kekana?
We can hear you, sir.
Sir, we can hear you.
Yeah, the thing is, when you are not responding, it's a problem, you see, because I can't see. The only thing that I'm seeing is this part. Okay. Any more questions on this one? Yeah, no, even if it's a length, how you work around it? Okay. This is how you work around it. maybe I'll suggest that you can take a screenshot of this and then look at it and see how they went about, especially here, because I see most of you will still be confused here. Ne? Okay. Yeah, take a screenshot and then work around it, and then maybe we can later on to want to play with this, because they've just do it they've just used the ratio. You see here they've got L/6, L/6, but when you are looking at this from there to there, it will be, so they've taken half of this. So once you take half of this, it will be 6/6, but if it's full, it will be 1/3. So you'll see also when you do this, the translation there. And here on the T, the M1G/2, they've taken this, so it was 2T here. Let me just do this pen. Pen here, it's 2T. So what they've done, they've taken this 2 to the other side. That's why it's MG1/2. Then that MG1/2 is the one that is being used there. Ne? So you can have a screenshot, and then because right now those who haven't done it, they will have less questions, but those who have done it, they could have had more questions. That's why I'm saying you should have tried this and see how far you can go. Okay. The babies here crying.
So
All
I
right.
just want to know, will you upload the solutions on Brightspace
Which solutions?
of these problems?
No. No, I don't think they'll be uploaded. As we are solving this, those who are interested, take a screenshot. Then that's it. Because sometimes you spoon feed people, give them information. Sometimes the information, when it's too much, people get overloaded. So if you are absorbing what you understand, I think it will be right. It's the same as if you are eating what you like. We cook, we give you masonja. If you don't want masonja, you don't eat it. We cook, we give you steak. If you want steak, you eat it, the steak. If you enjoy the steak, yeah, you know the taste of the steak. You get what I'm saying? So those who are interested will just take it from here.
Sir,
So with this, yes, sir.
so even this video, you're not gonna upload it on Brightspace.
No, the video will be there.
Okay.
The video is still there. You see, when I finish with this session, the video becomes available after an hour.
Okay.
So my problem now is I'm having a challenge in uploading these videos, but I've asked Mr. Fwam, because he's also had a struggle. There's a technique that he's using. I think he says he downloads them in the computer, and then from the computer there is a compression or what to MP4. He compress them to MP4, and then he uploads. Because when it's raw like this, it's difficult to upload. I don't know whether it's because of the space or what. But those who follow, you'll see on the chat of this, the video will be there. I think even after 10-15 minutes. You get it? That's the problem that I'm having. That's the problem. You see that problem that you are saying, Mine, you find that I download, but when I want to upload that site, it's just tell me that there's an error, or it plays only a bit. I download the whole thing, but it only plays a bit, but it gets to play the full video on the chat. So you see on the chat, you can watch it nicely from start to finish. But once it's downloaded, it's doing something there that I don't understand. But it's fine. What I'll do is I'm gonna try with this one, and I also want you to try and download it. Let's talk about the download maybe later on today on WhatsApp. And the one who can do a better download and compress to MP4, please send us the video, then I can upload it on the D2L. And that person will be the one who will be the download that will help us with this. Then send it to me, and then I upload. All right. Okay. Let's look at this one. This will be the last one that I'm gonna take with you. It says determine the moment M which the motor must exert in order to position the uniform, the slender bar of the mass M and the length L in the arbitrary position theta. The ratio of the radius of the gear will be attached to the gear bar, that of the angle wheel A attached to the motor shaft is 2. Okay? So this is what we are having. We've got the motor there. Can you see the motor at A? And this now being the gear. And can you see that the gear is attached to something there that I can't even see, but there is that bar with a length, and this motor, this gear is at an angle, that angle with the length, and we've got A, B, C. So the free body diagram of this is how it's being shown. I'll start with the motor. Can you see the motor one? So for the motor, this is how it will look like, because we've got the gear drive there with the teeth. The motor, when it's rotating this way, when the motor is rotating clockwise, the reaction there will be at A and at X, and somewhere there on the side of the reaction will get the force that causes the rotation. So the force will be to that direction. So meaning that when we are looking at this, like we said, we are only looking at the reaction. So this, if it's rotating anti-clockwise, the reaction will be clockwise. We've got that, and then the force there will be at that angle. So the same will occur here for the bar. This will be the length there, and then at the center point, that guy there who said the length, once you've got this, once you half it, you take half of it, the center point, it will be half the length. Then from there, you will have the mg. Yeah, you will have that mg, and here on the teeth itself, we still have the reaction because of that thing there. It's mounted on something there at the top there that I said I cannot see, and then here this will be the force, and then also we'll have the radius of that, which here they are saying that it will be the 2r. ne? 2r. Then when they take moments here, or when they started with this, they've identified the sum of moment at B will be 0, and they've taken this. Remember, we said force with a perpendicular distance. So when we consider the force here with the perpendicular distance, we've got F times 2r, and we also have this. Remember, we are taking moments about this point. So we also have this point, which is at an angle. So we'll have mg at that angle with that length. So when you are looking at it there, the other force here will be anti-clockwise, and then the other one will be clockwise. This will be anti-clockwise, the other one will be clockwise. That's why we've got a minus there, F2R minus that. So when you do the math, this is how your F will look like. Then same thing at point A, taking moments about the point A. So at point A, you'll have the M, which is anti-clockwise, which is clockwise, and then you'll have the F again and the R. You'll have the F and the R. So you'll see that the direction of the F will be anti-clockwise, and then the direction of this M will be clockwise. So they are saying they take anti-clockwise as positive, and then this is what they'll have. Then when you multiply, or when you solve this out, you'll have M, taking M to the other side, then you'll be left with FR. And where you see F, you substitute with this, and then the R and the R will cancel out. So you'll be left with 1/4 mg sine mgl sine theta. Then that's how you do it. Question? Question? Okay. So you see these two problems, or these problems. Kekana?
Yes, sir.
These two problems, or these problems, I've categorized them in terms of the ratio. So here they are talking too much about the ratio. So you will have to learn how to work with them, because if you don't, then you'll still going to have a big problem. You know the reason why we engineers work with ratio, just to remove the numbers. Just look at this here. You see, there is no numbers at all. No numbers at all. It's only 1/4. It's because of we are working with the ratio. If we could have said that the length here is 200 and the angle there is 60, then we're gonna be working with numbers. So you should learn at some point or now to work with the ratio. Any question on this problem? Okay. Not really, because they are honoring, or you find it honoring. So, but we have to throw in one or two there, because these papers, engineering body called EXA. So they want. I'm saying we're gonna throw in one question, 1 to 2 question on the paper, or one question of this nature. at least be there. Yes. More questions?
Sir,
Yes.
I just want to ask, at the moment at B, it's F times 2R. But isn't that force from the gear of A?
Come again.
The force F on B, where it says that F times 2R. Shouldn't, I'm just asking for, isn't F the force from gear A?
Yes, F is the force from gear A.
But why are we, oh, okay, well, oh, never mind. I see 2R is just the distance.
Okay. Yeah, 2R is the radius. Okay. Those who are seeing this for the first time, don't stress, relax, go and work through it and see. And yeah, so the reason why I've asked you to go through it, those who've tried to do it, yeah, could have questions that day. I was stuck, yeah, I was trying to do 1, 2, 3, 4. Okay. There is the self-assessment problem. There is assessment problem on that page. Please also, you need to do them hand in hand. Ne? And then today is Thursday. Please watch the 3D part of this. It's there on 2L. Just watch it like you are watching a movie. And then next week, we've been given a permission to use the practical periods. So I'm just gonna check what is the best that I can do. I'm just gonna check the timetable of the 3 groups and then see. But I'm thinking maybe Monday, Tuesday, and Thursday we'll have a class. At this time, I need to while there's still people behind. So that's why sometimes I'll just give time to let those who are behind full up. Like now, and a guy who had a problem